think I will start us off with our first demonstration. So, alright. This. Alright, so can I have everybody breathe in real quick? And then breathe out. What did you just breathe in? What state of matter? Oxygen. And what state of matter is oxygen in? Solid, liquid, or gas?
Gas.
Gas, that's right. So you didn't just breathe in oxygen, okay? So the air is made up of oxygen, but it's actually mostly nitrogen. So it's 80% nitrogen. So it's 4/5 of it. So if you look at the periodic table over there, you see on that in the yellow, the O is for oxygen, the N is for nitrogen. So they're right next to each other. They're very similar. And what you can do with gases is sometimes you can get them really, 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 really cold. Okay? And if you get it cold enough, the gas becomes a liquid. So what I have in here is something that's so cold that the gas has become a liquid, so I can pour it. So you can see I'm pouring it just like water, right? So, does anybody know what the temperature that water freezes at? 32 degrees Fahrenheit. Somebody's paying attention to this one. So, does it ever get that cold in Oakland? No, not really. So that's pretty cold though, right? Now I just have a little rubber ball, just a racket ball. Well, not right now, but we can put this into the liquid nitrogen. Well, yeah. So we just said that minus 32 degrees is what the temperature that water freezes into ice is, and that's really cold. Okay. The temperature in your freezer is about 5 degrees Fahrenheit, so that's even colder. That's why you can get ice cubes out of the freezer. Now, the liquid nitrogen here is a lot colder than even that. It's negative 320 degrees Fahrenheit. So that's really, really, really cold. Okay? So I'm just, putting the racquetball in there. You saw it bounce before, right? That's what racquetballs do. Yes, you have a question?
Like, what if we were touching you get serious flashlight if you put your face in this?
Yes, that's why you'll notice I'm wearing a very heavy glove so that I don't have to touch the nitrogen. I don't even have to touch the metal thing because that's going to get very cold from being in the liquid nitrogen. Okay. Well, you don't want it, you want to make sure that you don't touch anything that's come out of the liquid nitrogen, okay? The gas that you see coming off is just nitrogen that's evaporated away. So when a liquid turns into a gas, that's called evaporation, right? What's the reverse process? What happens when a gas turns into a liquid?
Condensation.
Condensation, very good. Okay, so this racquetball is about as cold as a racquetball will ever get, ever. So it looks pretty much the same. You can still read the pen on it. So, that didn't bounce.
That was my prediction.
Okay, so you'll notice that it broken to shards. Don't touch them just yet. They're very, very cold. Okay, but we can. I'll pass around. Here are some bits from another one that we did previously.
Yeah.
So you can see it's rubber, just like it goes right back to normal. So we already showed you that liquid nitrogen is very cold. And you can see the liquid nitrogen boiling, right, into a gas. So it's becoming a gas. And I can put the stopper on this. So what's happening is the liquid in here is evaporating, it's becoming a gas, and it's filling the balloon, okay? I know some of you are holding your ears, waiting for this thing to blow up. But so you'll notice that when I poured the liquid nitrogen in here, I didn't pour that much, right? Look how big this balloon is. This is full of the nitrogen that was in here. The balloon is bigger than the flask, and I didn't fill the flask. So what does that say about the relative densities of the gas versus the liquid? If not a lot of liquid became a lot of gas. Anybody tell me, which one do they think is less dense, the gas or the liquid?
Gas.
Gas, okay. Because the same amount of stuff takes up a much bigger volume, okay? So the other thing I want to point out between gases and liquids is that I could pour the liquid in here, right? And then it stayed. It didn't run away or do anything, right? Even though I didn't have a top on it. Now, what's going to happen if I let go of this balloon?
It'll go shooting around.
It'll go shooting around.
Catch it.
Exactly. So that means that liquids you can pour into containers that have open tops and they'll stay there. But gases, they have to be in a container that's closed on all ends. Because if you let one end open, that was one of the better ones, it's going to go everywhere. All right? So we just talked about the density, relative density between the liquid nitrogen and the gaseous nitrogen. You have a question real quick?
What happens if you were to tap that lightly, it'll break?
No, this isn't so brittle, but you don't want to test it. We wouldn't want broken glass because now that the rubber is fine because it's not sharp. But so we talked about the density and talked about that. Gaseous nitrogen is not very dense. Okay, but you cool it off and it becomes liquid. It gets smaller. Well, if you just cool off the gas itself, watch what happens to the balloon. Pour some more.
So it's solid? Is it
Okay. So, what's happening to the size of the balloon? It's getting smaller. And if the same amount of matter gets smaller, what does that say about the density? It's greater. Because what is density? Density is mass divided by volume. So, you notice, look how small this balloon is now compared to what it was. But I just took it out of the liquid nitrogen, so it's going to warm up. And what's going to happen when that gas warms up? What's going to happen to the size of this balloon? Well, it's not going to pop because it was fine when we started. But it's going to go back to normal size. It's not going to be as shriveled up as it used to be. So now it's the same size. You saw that it shrunk up when it got cold, but now that it's getting warm, it's getting big. So with that, I'm going to turn the